आज के चिंतन शिविर के संदर्भ परिचय के लिए मंच पर सर आपको आमंत्रित करता हूं।
गुड मॉर्निंग। Good morning, everyone. So, Chintan Shivir again. How many of you have attended Chintan Shivirs earlier? Almost everyone. How many of you think they were useful? नहीं, जबरदस्ती नहीं हाथ उठाना है. Okay. So, no, I am asking that because I want that this should be a one day well spent. ऐसा नहीं होना चाहिए कि you just think कि ये ministry ने चिंतन शिविर किया है तो we have to go, we have to attend and we have to speak something. Why are we organizing this one day discussion is basically what we wanted was that the top leadership of the companies or PSUs and ministry both should sit together and think about what is the way forward, what are the key strategies about steel sectors specifically related to public sector. Now, I am pretty new to steel sector, as all of you know. I have joined 2.5 months back, and almost all of you here have much more knowledge about steel than me. Many of you must have worked for more than 30 years, at least 25 years in steel sector. I have only 2.5 months knowledge of steel sector, and let me tell you that when I joined petroleum, I was as new as steel sector. So in 2014, I joined petroleum as joint secretary, worked there for 5 years, and I had no knowledge of petroleum before that. I had no idea what is upstream, what is downstream, how petrol is made, how diesel is made, what is crude oil. So, but it has its disadvantages as is very clear. But that's also an opportunity because you have a fresh set of eyes looking at the sector. What happens is that when you are getting into a environment or an institution for pretty long time, आप उसके used to हो जाते हैं. You think that's the way things should be, and you don't look at it from a fresh perspective. My request is please put your mobiles in a switch off mode. Because otherwise बहुत temptation होता है कई लोगों को. I know many people who can't remain without looking at their mobile after every 15 seconds or maybe after every 30 seconds. I had friends like that. वो रुकता ही नहीं है, हाथ मतलब चला ही जाता है कि किसी ने WhatsApp मैसेज भेजा हो. And I find that many people it is easier to talk on WhatsApp than in front, like face to face, because they respond better on WhatsApp than face to face. So I am just trying to say that I have the advantage of looking at steel sector from a fresh perspective. May not be new, but from a fresh perspective. And what are the few things which I think, with my limited 2.5 months knowledge or exposure to steel sector, we may have to work on. One, I think the steel PSUs have become very used to a particular way of working, and they have to look at newer ways of approaching maybe the same problems or different problems, but work in a competitive environment as PSU. Just look at after 90s where private sector has gone and where PSUs have gone. Private sector has been much more ambitious, much more expansion has taken place. They have taken many new fields PSUs have been conservative. Now I understand and I know that आप लोगों में से बहुत सोच रहे होंगे कि बहुत सारी problems हैं PSUs की. There is government control, there are CVC guidelines, there is audit, lot of things which are not there in the private sector. True. But still with all this, perhaps it will be better if we take a fresh look at what we are doing, how we are doing, and can we do it better. The second thing which I think is risk averse. PSUs are risk averse, they don't want to take risks, justifiably so perhaps. पता नहीं 3 साल बाद 5 साल बाद कौन बोलेगा आपने गड़बड़ कर दी. तो people are not ready to take risks, and in any business your returns are proportionate to a balanced risk taking. You cannot reach heights without taking some calculated risks. Just to give you an example, how many of you are from steel making PSUs? Lots. So when I see at the kind of coal blends which private sector uses and what SAIL or NSL is using, or RINL, I find that the risk-taking potential or risk-taking aptitude in PSUs is much less. PSU में होता है ये हमारा कोयला पिछले 30 साल से हम यूज़ कर रहे हैं, ऑस्ट्रेलिया का ये वाला ब्लेंड ये हमको बेस्ट रिटर्न देता है, लेट अस कीप यूजिंग इट. वाई टेक रिस्क, वाई टेक न्यू, कल को कम हो जाएगा क्रूड स्टील, क्या हॉट मेटल का प्रोडक्शन, तो हमको डांट पड़ेगी, अच्छा ये यूज़ करते रहो. And that basic, so what happens is that the person who is running the steel plant in that particular unit, he is not bothered about the cost benefit. He is bothered about the output. While everybody should think कि ठीक है hot metal कम आएगा, but हमारा cost कम पड़ेगा कि नहीं पड़ेगा. What is the net cost benefit analysis? So risk taking is another thing which I think needs to be, and related to that is overseas. Procurement, investments, steel PSUs have done very little in overseas investments. I think only thing is your Mozambique, maybe some Australia NMDC is doing, but as compared to the potential there is, we have very little footprint outside. So these are some of the issues I think we need to focus on, and I think this room has the most knowledge in steel sector in the country. इससे ज़्यादा knowledge steel sector की country में नहीं है. See, when I ask somebody, any of your our people की what are you doing about it, they say कि हमने एक consultant लगा दिया है. Now who is a consultant? In my opinion, a consultant is a person means an institution, team, whatever person, who comes, talks to you, gains knowledge about that subject and presents it to you in a very attractive PPT. उसके बाद अपना नॉलेज बहुत कम होता है. 25 साल 30 साल 40 साल के लोग होते हैं, वो जितना आपके एक आदमी को स्टील की नॉलेज होती है उनकी पूरी टीम को नहीं होती. बट दे कैन मेक बेटर प्रेजेंटेशंस एंड दे कैन टॉक बेटर देन आवर ऑफिसर्स. बट आई स्ट्रांगली थिंक कि जितनी नॉलेज इस रूम में है, व्हेन टॉप लीडरशिप ऑफ even private sector, if you think, most of the plants are being run by ex-SAIL, ex-NMDC people. So, we have the best of people, best of leadership in the country in steel sector here, and if something is to be done, it can be done, it should be thought about here. And one more thing which I want to talk about is technology and AI, machine learning, deep learning, process technology, how to leverage technology, because without using technology, we are going to go nowhere. just one question. What is the difference between artificial intelligence and machine learning? ये मुझे कल पता चला है, इसलिए मैं पूछ रहा हूँ. How many people know that? One, good. Two, please tell me in the back.
Artificial intelligence is working, machine working at human intelligence level.
Okay.
And machine learning is data manipulated by machine, use data manipulated by machine.
More or less what I was told. So I did not know about it. Please sit down. कल मैंने iGot में वो कौन सा iGot प्लेटफॉर्म में AI का एक कोर्स में एक मॉड्यूल देखा, तो there I understood what is the difference between AI and machine learning. Now I am just saying that because this is the new field which should be used by PSUs if you want to move forward, because without this there is no future for getting maximum benefit out of your machines, whatever you are doing. कोल ब्लेंड्स आप जो पिछले 50 साल से यूज़ कर रहे हैं, उनके डेटा को यूज़ करके व्हाट इज़ द ऑप्टिमल कोल ब्लेंड और व्हाट इज़ द न्यू कोल ब्लेंड यू कैन यूज़, दैट कैन बी प्रेडिक्टेड बाय अ मशीन लर्निंग एल्गोरिदम or even a deep learning algorithm. So technology is one more, and that's why we have kept a session today. So I would think that today's day is a well spent if at the end of today we at least have some idea of what are the new things we want to do. Whatever we are doing, fine. What are the new things? If everybody who leaves this hall thinks that they have learned one or two things which they would like to do. So, and during discussion, I would request that everybody should contribute. If they have a question, they should ask. In today's discussion, there is no hierarchy, so everybody should feel free to ask questions and give suggestions. And I hope that today's day will not be not be boring, but rather a day where we will think कि हमने कुछ किया. Thank you.
बहुत बहुत धन्यवाद आदरणीय सचिव महोदय. सचिव महोदय ने इस्पात क्षेत्र की चुनौतियों और संभावनाओं पर प्रकाश डाला और अगले सत्रों की पृष्ठभूमि को हमारे समक्ष रखा. मैं आज की इस चिंतन शिविर के पहले सत्र, जो कि जिसकी थीम रखी गई है तकनीकी उन्नयन, आर्टिफिशियल इंटेलिजेंस एंड मशीन लर्निंग, मैं इसके प्रमुख वक्ताओं को आज मंच पर आमंत्रित करना चाहता हूं. प्रमुख वक्ता के रूप में श्री वेद प्रकाश, कार्यपालक निदेशक, डिजिटल ट्रांसफॉर्मेशन डिवीजन, स्टील अथॉरिटी ऑफ इंडिया लिमिटेड. सर, आप आमंत्रित हैं मंच पर. और इस सत्र में अन्य वक्ताओं के रूप में हमारे साथ रहेंगे श्री सत्येंद्र कुमार, कार्यपालक निदेशक NMDC, और श्री विजय कुमार, मुख्य महाप्रबंधक, कंप्यूटर एंड ऑटोमेशन, बोकारो स्टील लिमिटेड, स्टील अथॉरिटी ऑफ इंडिया लिमिटेड. और तीसरे वक्ता के रूप में हमारे साथ रहेंगे श्री चिराग सिंधु जी, वरिष्ठ प्रबंधक, MSTC लिमिटेड. आप तीनों महानुभाव इस विषय पर प्रकाश डालेंगे. धन्यवाद.
A very good morning to all. Respected Secretary Steel Sri Sandeep Pandit sir, Joint Secretaries, and all the esteemed dignitaries, CMDs, Chairmen, Directors, EDs, and my dear friends present in this hall. It's our honor to be present here and to share the dice with the August gathering here for presenting the latest trend in the steel and mine sectors. In today's first session, we will be delving on the topic of AI upgradation, machine learning, myself Ved Prakash, EDDT in the cell, And joining me is my colleague Vijay Kumar, CGM in SAIL. And together we will be presenting an overview of the digital implementation case in the SAIL. Following the next session will be held by the Mr. Satyendra Rai, who is the EDDT and NMDC. And then the floor will be shared by the Mr. Chirag Sindhu of MSTC, and they will continue their implementation in their company. As we all know that AI and the machine language have penetrated deep into our human sphere of life, maybe it healthcare, agriculture, banking, insurance industries, and AI is transforming the industry in a big way. And the steel sector is in no exception. The overall company has the two verticals. One is the IT network, which manages the frontline activities like HR, material management, personnel, finance. And second is the OT network. It focuses on the actual monitoring, controlling the physical industrial process and the real-time monitoring in this. This is the order of presentation here. First case will be deal with the AI/ML in the steel and mining operation. Second is the digitalization journey in the SAIL and the roadmap. And third is the actual implemented case in the SAIL regarding the AI/ML. And last is the way forward and the technology upgradation will be taken by the Mr. Vijay Kumar. As we all know, the three basic pillars of industry, a smart industry factory, is the 3 Ds. First is the digitization, which consists of digitalizing all the documents, manual, P&I diagrams into a digital form, which is very essential. We are doing, we have converted all the important documents, process PI diagrams into the digital form. Second is the digitalization, which is the actual implementation of model use of AI/ML in the various process, right from the Cocoa 1 to the mines, Cocoa 1, and right to the rolling mill sections. Third is a very important digital transformation, which is the actual building an ecosystem and a cultural change in an industry to carry over the further digital initiatives in future. This is the broad view of the entire value chain where the AI/ML can be applied: human resource, safety, finance, sustainability, and furthermore in the various process, inbound logistic, iron making, steel making. On last row depicts what are the ways how the AI/ML can be implemented. Blend cost optimization. This is the general overall view of how the AI/ML can be used in mining, exploration and the land clearances, project and mining planning, mine operations. These are the basic area of domain where the AI/ML can be used in the mines. This is the 4-step, the digital journey of the SAIL. Recognizing the potential of AI/ML in the steel manufacturing, SAIL embarked on its journey to the digitalization in 2021. As a first step, a Apex committee was formed and comprising of senior management officials from each integrated plants, mines, and the marketing divisions. The committee was chaired by then director in charge of our plant, Bokaro Steel Plant, Sri Amrendu Prakash ji, and now he is now the chairman of the SAIL. Under the committee guidance, various units across the SAIL start beginning the implementation of smaller initiative at the local level, exploring ways to harness the power of AI/ML in daily operations. And third is the expansion in all the greenfield and brownfield projects further. We'll be having the IoT 4.0 platform there, and all the AI digital models will be incorporated. And last is the final digital transformation. It is actually forming a digital culture in our steel sectors and leveraging the data-driven insight into the decision making. These are the basic domains in which we have worked. We have done the digital implementation. First is the process modeling. Here we have done this implementation in coke oven, blast furnace, steel melting, and CRM. I will explain the case, some few cases, sir. Whatever you told just now, coal blending system, I will be delivering on this also. The asset monitoring is the second important thing, where all our rotating machines have been sensorized with the temperature monitoring, acoustic and vibrations. All data are being taken, and the health and the predictive analysis is done. We also have the prescriptive analysis also. Like this centralized visualization dashboard, safety and surveillance, machine vision, computer vision for detecting the defect in the output product online. And last is the cyber security. Sir, these are the various initiatives domain-wise and the respective plant have implemented. A total 277 digital initiatives, some are employing the AI/ML also, have been completed. 175 are completed and 102 is ongoing on. This project, this digital intervention covers all these major domains. So here I am presenting some few. Actually, we have done more than 3 to 4 cases in each of the process section, right from the cocoa one. But these are the few which are very important, like development of blast furnace digital twin. Here we have developed the 4 models: cohesive zone prediction, deadman cleanliness, silicon prediction. So I will explain any one of the cohesive zone model. Actually, blast furnace is a very complex process of smelting the iron ore into the hot metal using coke and hot blast as a reducing agent. Few years back, blast furnace was considered as a black box. Once the material is charged, and we cannot know the composition and the quality only after the analysis of the tapped hot metal. So nowadays, with the sensorization, smart sensorization, and leveraging the digital tools, the behavior of furnace and the composition can be predicted. Here is the metal, burden is charged from the top, and from the hot blast is given from the tour in the bottom. And the ideal shape should be a vertical V for better gas utilization, reduce the fuel rate, and the maximum productivity. So here inverted V shape, when the gases are formed, they move upward, and there is a temperature change at the various stakes. Next. These are the different stack temperature. Belly is the lower portion, and S1, S2, S3 are the various stack temperatures. So when from the beginning, here is the identification of the bottom of the V is important, and the height of V is important. So bottom of V is actually calculated by the models by considering the temperature at various states, stack temperature, and there is a change of temperature. The start of the bottom of the V is, there is a bottom of the V. And similarly at the top, the width and height of the V curve, V shape, determines the actual performance of the blast furnace. Back. So by studying the various pattern, we can predictively say, what could be the shape of this V shape, and operator can control the process, and they can distribute the burden according to the desired V curves. This is successfully running in our blast furnace of ISP and BSP, Bhilai Steel Plant. And we will be repeating it to the other blast furnaces of our plant, sir. So second is the health monitoring of our critical rotating machines, which covers the pumps, fans, conveyor belts, and all this. So by sensorizing is all the motors, this dashboard, all the signals will come that whether the motor is healthy or not. The red sign motor shows that it is a healthy, non-healthy condition. Back. Sir, here we measure the vibration, temperature, and the acoustic of the motor, and by this, if any motor is going to be faulty, will be detected, and the warning comes in the dashboard, sir. And in the neck, enlarge. So if we click individual motors, its running parameters can be, if we click any of the this motor or equipment, the running parameters will be displayed, and what are the threshold where the signal should come will be displayed, and if any running signal comes out of a range, then the warning will be displayed, and what could be the problem will be displayed there. This is a prescriptive type. Suppose bearing is loose or there is a alignment problem, looseness is there, that will be displayed in the. Similarly, this is another asset performance measurement, like the conveyor belt. We have the huge network of belts in the plant, right from mines to the all hot zone. So here any foreign materials like angle, channels can be detected by video analytics. A camera vision is there, and the AI/ML algorithms are applied so that any foreign materials and any unwanted materials can be detected before it goes to the. So it also take care of the health of the belt also. So we have the less breakdowns like tearing of the belt and like this, slipping and tearing. Apart from this, if there is a sway of belt to one side, that is also detected. So there are two models in COCO 1. One is the coke quality prediction in advance. Second is the coal blending model. So here first I am explaining the coke quality prediction. So when coal is charged in the batteries of the COCO 1, we heat it to the 72 hours. Then only after we can know the quality of the coke which is used in the blast furnace. So we have applied a model there. So we have the different blends of the coke coming from the various sources, 3 sources, 4 sources, and the composition can be different in each source. So before it is charged to the oven, we can know what could be the outcome of what could be the properties of the coke after the 72 hours when it is heated. So this model is running in Bhilai, and we will be replicating it to the other steel plant also, sir. These are the various graphs. We can predict the quality of a coke which will be come out after the 72 hours up to the 95% accuracy. This is the graph. So this is our CMO has applied a AI-based theme in the chatbot for the customer. So till now we have the web chat of near about 1500 hits and the WhatsApp 173 total. It is in a 5 months. So similarly, apart from the process, we have applied the AI/ML in the news reading also. Bokaro steel plant, we have the Bokaro Darpan news channel in which the plant total news will be covered. So AI/ML based chat, this news reader is there. So this is one of the main very important implementation we have done is the SDGL line of Bokaro steel plant. And we have filed the patent also for this. This is actually when cold rolled coil passes through the hot dip galvanizing pot. So there is a deposition of zinc in that. So thickness of zinc can be predicted in advance by this algorithm. Though we have the thickness gauge, zinc thickness gauge, but once it gone bad, करीब हमको लगता है कि 1 साल तक ये डिफेक्ट आ गया था गेज में. ये फॉरेन मटेरियल था, थर्मोफिशर का गेज था. उन्होंने बोला कि 6-7 महीने लगेंगे हमको इसको बनाने में. हमको शिप करके भेजना था बाहर और फिर आता. तो इसमें हमारी टीम ने ये एल्गोरिदम लगाया कि ये जो वर्टिकल जो सेक्शन है वहाँ से कॉइल जा रही है और सामने जो एयर नाइफ है, 2 एयर नाइफ रहते हैं, एक शीट के एक तरफ एक दूसरी तरफ. तो एयर नाइफ से एयर प्रेशर हम देते हैं. जब भी जिंक कोटेड आता है तो वो फैलता है शीट के ऊपर. तो कितना थिकनेस होनी चाहिए वो कंट्रोल वाल्व से कंट्रोल होता है एयर नाइफ दोनों. तो उसका एक प्रेशर पे डिपेंड करता है, डिस्टेंस फ्रॉम द शीट डिपेंड करती है. तो इसका एक रिग्रेशन मॉडल अप्लाई करके प्रिडिक्शन ऑफ कितना जिंक पर जीसीएम ग्राम पर स्क्वायर मीटर ऑफ सरफेस जा रहा है. तो ये मॉडल करीब 98% एक्यूरेसी से काम कर रहा है. थिकनेस गेज बनने के बाद हम लोगों ने जब चेक किया, देन ऑल्सो इट इज ए कंपेटेबल की सही काम कर रहा है. तो this is the just similar to the quality prediction. It is a coal blending model which is developed by our RDCI's research and development wing. Here we have suppose we have the various blend. We can put the percentage blend of each in the column and we can see what could be the desired coke properties. एक मिनट बैक. सर इसमें अगर हम देखते हैं कि कितना परसेंटेज हम डिफरेंट सोर्स से अगर कोल डालते हैं तो हमारी जो कोक की फाइनल जो आउटपुट होगा उसकी क्या प्रॉपर्टीज हो सकती है, CSR, CI, M10, M1020. तो इधर से हम देख सकते हैं कि किस तरह से ब्लेंड किया जाए कि हमारी प्रॉपर्टीज जो है कोक की इस तरह. तो ये मॉडल इज सक्सेसफुली रनिंग इन ऑल द प्लांट्स. So these are the few models, silicon prediction in advance, what could be the silicon percentage in the hot metal. तो ये सब मॉडल में हम लोग ने बनाए हैं सर, that are successfully running, and slowly we are covering to all the blast furnaces by sensorizing. किसी blast furnace में sensorization कम है तो उसमें हम लोग सेंसर लगा के ये. सर इतना इम्प्लीमेंटेशन हुआ है, बट स्टिल टू हैव ए रोबस्ट इंटीग्रेटेड प्लेटफॉर्म और एंड टू बिल्ड द डिजिटल इको कल्चर इन द कंपनी. तो वी आर हायरिंग ए डिजिटल कंसल्टेंट, रेपुटेड कंसल्टेंट इन दिस फील्ड लाइक अदर पब्लिक सेक्टर्स, कोल इंडिया, ऑयल एंड OIL. This is the roadmap. The first 6 months will be the roadmap preparation of sale as on status of digital maturity and to be status. Gaps will be identified. And second is the 24 months implementation period. The key, next. So the key deliverables is the party has to demonstrate 1,000 crore minimum benefit from the implementation of digital tools and AI, and the building a robust ecosystem in the company. तो ये इसका हम लोग ने टेंडर आउट कर लिया है सर, और इसका सून विल बी कॉन्ट्रैक्ट विल बी अवार्डेड. सो इसके अलावा सर जो हमारी टेक्नोलॉजिकल जो ऑब्सलेंस है उसको हम लोग ने किस तरह से ओवरकम किया है कि जो हमारे सर्वर्स हैं या लीगेसी सिस्टम है तो उसको हम लोग वर्चुअल प्लेटफॉर्म में किस तरह से लाया है. तो दैट विल बी कवर्ड बाय नेक्स्ट स्पीकर मिस्टर विजय कुमार. नहीं, हम लोग के सबको हमारे पास 4 सोर्स ऑफ कोल है और इसमें परसेंटेज डिफर कर रही है कि किसी में एस ज़्यादा है, किसी में ये है. तो उसको किस तरह से ऑप्टिमम ब्लेंडिंग हम करें, कितना परसेंटेज डालें कि हमारा की जो कोक क्वालिटी आएगी, जो डिजायर्ड कोक क्वालिटी है। हाँ, नहीं, 4 सोर्स के अलावा 5 सोर्स भी हम लोग, ऐसा नहीं कि 4 ही सोर्स से हम कंटिन्यू हो रहे हैं। तो
We are using 19 types of coal. Normally, suppose we are using 12 is the hard and 6 is the soft and 1 is the PCI. Now we are also searching for the new source, and for the last 1 year I can say that we have find the sources, 12 sources are there, and we have done the technical specifications and lab testing and all that. And out of 12 sources, we found that 6 sources are fit for using in our coke oven. Now, these 6 sources are doing the coal blending model is being used as RDCIS, so that where and in which plant these sources can be utilized. Thank you.
थैंक यू।
So this coal blending AI model which you are using, what I understood was that you have certain number of sources, and the percentages you are compositions of those sources you are deciding based on your model.
Yes.
My question is, why can't we, so going beyond this, two parts. One, that why are we stopping at coke? Means I would presume that if your AI algorithm is strong enough, you should be able to predict the hot metal output based on the coal you are using, based on the AI model. That is number one. And number two, you should be able to, so you get a new source, suppose a proposed new source. It has certain chemical propositions and whatever. You should be able to directly put that into your model and find out whether it is working or not, rather than going through first a longer process of your whatever department is deciding of doing all that, and then after deciding that okay, we are going to use this coal, then you are only talking about the blending percentage. So ideally, and I don't know whether it's possible or not, but ideally, by just entering the properties of the new proposed coal, you should be able to predict whether it is working or not working.
Sir,
Good morning, sir. I will come to this. Thank you very much. Good morning to all delegates. And sir, thank you very much for setting the context such beautifully. I am very sure that I am in the right place to speak about things, and this discussion today will lead us to some bright future in field of AI ML in this. Whatever we have talked in this and whatever has been discussed will not be possible without a fertile, very fertile IT landscape, and that we identify very early and implemented in our plants. We have to take this all to a virtual platform. We have moved all our machines to virtual platform. Allow me to illustrate this with a very simple example. What does this mean? Suppose there is a plant in a garden. Now if this plant is put in a pot, then we can consider the pot as a virtual environment and the plant as an application. Now think of the flexibility we have. This maintaining this pot, we can have different size of pots for different plants. We can have different quality of soils for different plants. We can have a more secure environment for that pot. Moving this pot from one place to another place becomes easy. So all these agility comes with creating a cloud at the premises.
सर
And-
विजय, एक मिनट सर, आपने जो क्वेश्चन पूछा था मैं जस्ट उसका
Okay.
सर जो हम दो सर इसमें मॉडल है कोको वन में सर कोको वन में दो मॉडल हम लोग यूज कर रहे हैं। एक तो है कि इन एडवांस कोक की क्वालिटी क्या होनी चाहिए वो हमको पता चलेगी। पहले था कि हम जब कोक बन जाता था हमने ब्लेंडिंग कर ली, कोक बन गया, उसके बाद उसको हम लोग टेस्ट करते थे ये क्वालिटी आ रही है तो उसके हिसाब से ब्लास्ट फर्नेस जाती थी। अभी है कि हमने अगर 4-5 सोर्स से कोक को ब्लेंड किया, सबकी प्रॉपर्टीज अलग हैं, किसी में एश कंटेंट एंड अदर जो भी है CSR M10, तो उससे हमको पहले इन एडवांस हमने फीड किया मॉडल में ऑफलाइन, मतलब एक ट्विन टाइप की है, एक्चुअल रिप्लिका ऑफ द प्रोसेस ट्विन बना ली, तो उसमें फीड की तो उससे हमको आफ्टर 72 आवर्स हीटिंग होके जो कोक बनेगा तो उसमें क्या क्वालिटी आएंगी हमारी CSR M10 जो है वो प्रिडिक्ट होती है। दूसरी चीज़ सर आपने जो सही बोला कि जो ब्लेंडिंग ऑफ द कोल जो है कि हमारे पास डिफरेंट सोर्स हैं तो उस ब्लेंडिंग से भी हम किस तरह से हमारी जो कोक की क्वालिटी किस तरह कोक में किस तरह के पैरामीटर्स आएंगे वो भी एक अलग मॉडल चल रहा है जो कि RDCS का मॉडल, उसमें आर्टिफिशियल इंटेलिजेंस अभी हम लोग उस पुट करने के लिए अभी काम कर रहे हैं। अभी हम लोगों ने जस्ट मैथमेटिकल मॉडल से वो प्रिडिक्शन आ रहा है, बट सून विल बी पुटिंग द आर्टिफिशियल इंटेलिजेंस इन दैट ऑल्सो।
Sir, myself, PDRD, sir, Sandeep Kar here. Sir, can I add few sentences, sir? Sir, myself, Sandeep Kar, can I add a few sentences? Actually, whatever at RD says, whatever model we have predicted, because coal is having some inherent properties, maybe as volatile matter, these are the extensing properties, but carburization is also a very great properties. So there are some formula is available. So at first what we used to do, whenever we getting a coal, we in our pilot oven, we are checking in which category it falls. Bitrinite percentage, its mackerel value, as per that we characterize that coal. And when it will be blended in the bigger oven, how much it will come. So different theoretical formula is available. As per that, we have made a model through which we can say, yes, this coal, after doing the carbonization at our laboratory, this coal can replace that coal. So initially, with different blending, we are making at our pilot scale studies at RDCS. Then we are telling to the plants, now you can replace this Australia hard coal by this percentage.
That is not the question that you are already doing. I think, I don't know whether. So my question, would you like to?
नहीं सर ये कह रहे हैं कि से ऑन बेसिक साइंटिफिक प्रिंसिपल्स इफ़ आई नो कि एक कोयले में ये 10 प्रॉपर्टी है तो मेरा क्या होगा, तो आई नाउ आई नो कि हमको ऐसा कोयला खोजना है जिसमें कोई भी कोयला हमारे पास अवेलेबल है, या हमको इससे इन्फीरियर कोयला है जिसका विट्रिनाइट परसेंटेज, जैसे आपने बोला एक फैक्टर है, तो विट्रिनाइट परसेंटेज आप बोलते हैं आज के दिन में 1.15 से नीचे होगा तो हम इसको नहीं लेंगे, हम नहीं यूज़ कर सकते हैं। तो कैन यू हैव दिस, कैन दिस बी प्रेडिक्टेड बाय योर मॉडल कि 0.9 विट्रिनाइट का अगर कोयला है तो क्या हो जाएगा?
Yes,
Can
sir.
it predict? So at the scientific level, not at the practical pilot oven or industrial testing से पहले ही बेस लेवल पे हो जाए। जैसे फिजिक्स डेवलप किया है, केमिस्ट्री डेवलप किया है, तो नाउ आई नो कि सेब को यहाँ रख के छोड़ेंगे तो यहाँ गिरेगा, किस स्पीड से गिरेगा वो सब कैलकुलेट हो गया। Like at that level, once your model is at that level, then any coal, any material that you want to charge, it should be able to predict. Sir, I think that was your thought.
Sir's question is different. I think what he's saying is, no, going beyond coke. Why can't you
Next phase.
First is you are stopping,
Stopping at coke.
Stopping at coke, not going up to hot.
Yes, sir. We are going, till in this model, going up to coke only.
So that's my first question. You should have that okay, and not only coke. I put X coke, Y iron ore, Z manganese, whatever you are putting. I put all of this. What will be my hot metal? What will be my steel? Whatever. This should be the overall model. You should be. That is the ideal model. Right now you just have a component
End-to-end.
of that model.
Yeah.
हाँ, तो उसके लिए सर ये है,
but abhi,
Hey, that's my
that's
first
the first.
Second is, you are saying that we have 15 or 18 or whatever sources of coal, and we are only deciding the blending percentages or exploring the blending percentages based on our predictive model. What I am saying is, machine learning is not limited to that. Machine learning is that basically based on patterns of use, and you have so much data of 50 years. So based on those patterns, the machine should learn from those patterns.
Yes, yes, sir.
And say that, okay, if you put X coal, and then this will be your output. So ideally, you should not have to go to your actual testing before using the AI model, and AI model should tell you that, okay, this is workable, then only you should go into physical testing. Right now it is the opposite. You are doing first the physical testing, then using the AI model.
So you are absolutely correct.
sir,
I
this
mean,
model-
all this data, all this has been developed on historical data, on neural network, and we are doing this, and we can predict if this coal parameters, if the suppliers give us, we can predict how that particular coal is likely to behave in our coke oven. However, the proof of the cake is in eating it, so we test it also. So validation, it's a kind of a validation because and and as more data is generated, more accurate it will be.
नया नया कोयला लेकर ट्राई करते हैं डाटाबेस बढ़ाना
Also, right now, I have a code I'm testing. My demand from the team is, today you say, when I buy a coal, I want a range of specification. My ash should be 8.5 to 9.5. My vitrinite should be 0.9 to 1.1. So many other parameters is paid. This is a range. What I'm saying is, can your model at some stage go and say, forget the range, I'm giving you a new range. Right now, based on your experience, what coal you have used, you are giving this range. Can the model expand that range? Can the model say, nahi, vitrinite 0.5 se leke 1.5 tak chalega? Then I will go and find more coal. Otherwise, right now I'm bringing in a coal and then you are testing.
I mean, no, the issue is the model still works on historical data.
Exactly.
So whether it has learned that much, that when it can do a predictive thing.
So ML ho gaya hai, AI pe jana hai. It has to develop the intelligence to say that
because the model might not have seen that kind of vitrinite. So that's the
maturity
issue.
model mein probably, I guess, sir, this will grow and then get to that level.
One more step is when you say that even if the whatever, suppose coke, it is beyond your range. Even if it is beyond your range and your output is not optimal, whether it still makes cost benefit, so whether it still
Overall
makes
cost
sense
model.
from the economic point of view.
Yeah.
Because ultimately it's the economics. So my impression till now is that the economics, means director of finance part or whoever is buying coke, and the technical part, they are not in synergy. That's my impression. I may not be correct, but they should be. It should be ultimately the operational person also should look at only at the cost.
Correct.
Sir, we do that.
Up till one level it is there. That means right now they are saying कि मेरे पास ये 10 कोयले हैं, तो बोलता है उसका जो आपने बोला परसेंटेज कितना चेंज करेंगे तो मेरा कॉस्ट कितना चेंज होगा, that they are able to do right
Because
now.
the cheapest blend may not lead to the cheapest hot metal. So that we also keep in mind, because if I make the cheapest blend, which is theoretically possible, however, if my coke properties gets impacted adversely due to that cheapest blend, that may impact in a suboptimal blast furnace operation, then we do not go for that blend.
That's
So we are doing those things. No, we are going. Because looking at the properties of the coke, you can predict in the blast furnace model how this coke is going to
When I
behave.
was working when I was the head of IT for donkeys years. What happens is, the difference is the problem definition. What the top management defines as your problem. If you define your problem at the coke oven level, it stops at coke oven. The best software that I have ever seen is the railway reservation system. There's no, but it stops at ticketing. It stops at ticketing. It does not go beyond that because you have defined a problem. कि मुझे टिकट इशू करना, रिजर्वेशन इशू करना, ठीक है. Now that amount of data, you don't take it one step beyond to analyze your earning, कि कौन सा routes
Optimum है, passenger load, etc., etc.
Because I have handled that software for 7 years.
Yes.
So I know कि what sir is saying is about problem definition. That when you go to blast furnace level, it's a different level of problem definition. The software that will be developed, the learnings that will be developed would be of a different parameter that, as you said, the cheapest quality of coke will not give you the cheapest quality of hot metal. That comes from sir saying, where do you end it?
Basically, I am asking this question. The first steel plant I went to was NSL. Okay. NSL mein one of ex-sale employees looking after his blast furnace, Mr. PK Singh. Now, he said, so we were having discussion. Now, NSL plant has the latest technology. कितना अभी just 2022 में चालू, they are the best of technology, everything. Mr. PK Singh said, मुझे तो यही कोयला चाहिए. Because that's the koila he has been using for 40 years. Is it the best utilization of 2022 plant? That is the question I am asking. ठीक है? Because जब 1980 में आप चलाते थे blast furnace, तो हो सकता है आपको ये कोयला चाहिए. Because that was limitations of the blast furnace. 2022 में आपको वो कोयला नहीं चाहिए perhaps. You can use a much worse coal with better technology and everything. So that's what I am saying. And we are stopping at blast furnace, but it should be ideally everybody in the plant or in the sale should talk only about cost. Not about कि हमारा output ज़्यादा होगा, हमारा ये ज़्यादा होगा. Right now people think about their units. Blast furnace वाला अपना unit सोचता है, coke oven वाला अपना unit सोचता है. तो इसलिए PK सिंह ये नहीं, PK सिंह साहब भी चाहते हैं कि उनका प्लांट अच्छा चले, लेकिन उनको लगता है कि ब्लास्ट फर्नेस से हॉट मेटल कम निकला तो मेरे ऊपर आएगा. बट वो नहीं होना चाहिए. अगर कोयला, मान लीजिए आपने खराब कोयला डाला और वो इतना सस्ता है कि कम आउटपुट में भी इट मेक्स सेंस, तो इट शुड बी ओके. तो दैट्स व्हाट आई एम ट्राइंग टू से. ओके, लेट अस सी.
सर, आई विल जस्ट लाइक टू कंटिन्यू ऑन दिस व्हाट वाज गोइंग ऑन. मान लीजिए, हाँ, मान लीजिए सर, मैजिकली वी हैव अ मॉडल ऑफ ब्लास्ट फर्नेस जहाँ पे हाइपोथेटिकली वी कैन सी कि व्हाट आर द थिंग्स दैट कैन बी पुट इनटू ब्लास्ट फर्नेस टू हैव द बेस्ट आउटपुट फ्रॉम द ब्लास्ट फर्नेस. एंड इफ द मॉडल कैन बी फेड विद डिफरेंट टाइप ऑफ, देयर आर टू थिंग्स, क्वालिटी एंड क्वांटिटी ऑफ different materials, iron ore, flux, coke, what are the different types of coke that can be fed. So, whatever coke that has been fed in all the blast furnace across the globe, they have come to a conclusion that these are the quality of coke we need to run this blast furnace optimally. Now, we are breaking it in two parts. The best possible quality of coke to run the blast furnace, quantity of coke that has been best ever used in whatever blast furnace, the best of the blast furnace. Now our challenge remains, can we produce this quality of coke with whatever available coal we have? Or can our model answer this question, whether these available coal will be able to produce this coke? Yes, the model we are using can be fed with the inputs of the available coal, and it can give within the parameters of acceptable coke for the best quality of production, for the best optimized production. It can predict what is the quality of coke we can expect from the given input of coals. So that part is taken care. When you are saying that we should look forward across, we are planning this, we will cover in this. There is end product, our sheet. There is a defect in the sheet called ridge. We want to find out whether is there anything built in the quality of coal we are using to have something with the ridge. Is there something has happened in the blast furnace which might affect the quality of ridge in the last end of our mill. So we are in the process of accumulating this data, connecting this data, to make more meaning out of whatever data we have. And of course, sir, as you said, we understand we are right now running these models of blast furnace, of coke oven, of our mill in isolation. But we are in the process of integrating these data to derive a better story across the different units of the different units we are running. And this is where, that is why we have put all these things on the local cloud there, so that proximity of the data, feeding this data to different models becomes easier. And, okay, sir. So we have a local on-premises cloud to test all the models, data, different models for different units of our plant. We have, and as I said, when we virtualize, make an environment like that, put the plant on the pot, virtualized environment, that gives this much, it gives scalability, it gives reduced hardware dependency, it is reduced downtime, cost efficiency. All this comes along with that a fertile IT landscape environment. PLC is a very important part of collecting data, interpreting data, and giving input to the models. Running these PLC in the harsh environment of the industry is a challenging job. We have virtualized that. Today's simple PC is much more powerful than PLC we have in years. So these PLCs can be emulated as a virtual environment in a PC. And then this gives us opportunity to test many things in that virtual environment, so that we have created a virtual PLC in our environment, so things can be tested there. Next. And this is what, as you said, that these models should be integrated together. So this is what we are trying. This is a predictive model, this process optimization, quality control, all this value chain should talk to each other to define each other, set the context between the relation of all these units, different parts. Like our marketing should have input from our processes. Our sales should have input from our production. So this is the next thing we are working on. Getting certified is important. We might be doing good things, but certification makes you recognize. This IT neural network is very old thing. It is nothing new. This is almost 50 years old. But only this year, that Swedish Academy of Science, Royal Swedish Academy of Science has given Nobel Award to Jeffrey Hinton for AI in physics. Only this year. They thought it is important to recognize that. People will understand why a Nobel Award has been given in AI field. We want to certify ourselves to the global benchmark. So we inspire and aim to become a global lighthouse. It is a certification given by World Economic Forum. It is given to the people, to the industry who are based in this. So we have given ourselves a task, a target to get certified as a global lighthouse, because by doing that we will be aligning our activities towards digital transformation as the best players of the globe. Okay, sir. So we are setting our ground and activities aligning so that we can get certified as a global lighthouse from the World Economic Forum. And now I invite my next speaker from NMDC. Thank you, sir.
Respected Secretary Steel. Okay, sir. Okay, sir. So I'll talk about digital transformation, that some of the, initiatives that we have implemented and what we have the road plan for the future. Next. So my presentation flow talks about industry perspective, digital transformation roadmap that we have for us, digital initiative implemented, and master plan for future digital initiatives. The presentation is on these lines. Next. So as we see in the mining industry, the challenges are with respect to production, productivity, efficiency, sustainability, ESG. So these are the areas, safety, these are the areas where we want to bring in digital intervention to improve our processes and achieve metrics which are at best with the industry best practices. And please go back, yes. Previous screen. So here I would also like to mention, if we talk about mining industry, generally it is considered to be 30 or 40% less digitally mature than other manufacturing industry. This is one constraint. And global digitalization in mining market is growing at a rate of CAGR of 11.3%. Next. So these are the areas, if I put it into three buckets, where digital interventions we are planning pertaining to area under exploration, operations, and enterprise. We'll start the cycle with the exploration, then the operation part, products and dispatch, and then the overall back office and process improvement is part of the enterprise. If we talk about technology, my predecessors have already talked about a bit on what is AI, what is ML. If we talk about we need to modernize our IT infrastructure from where we are, on which we have already placed the order. Like we didn't had entire Wi-Fi connectivity in our entire mines. So for many interventions to work, that is the basic thing which we require. So if you don't have a network or a Wi-Fi connectivity in the mines, any IT digital interventions, be it fleet management or any such interventions where we are using automatic machines to capture data automatically, a network has to be there so that these intelligent machines can talk with the back-end system. Then cloud computing we are talking about, or the ERP which we have implemented is hosted on our cloud. Then advanced analytics, robotics and AI.
All this theory is okay.
Just the areas, yes sir.
You all know the theory.
Fine, next sir.
Move into something that's applies.
Okay, sir. Sir, basically, we are producing a 45 million ton currently, and we have a plan to scale up to 100 million ton of production by 2030. So our vision is also in line with this. The plan what we have is also in line with this particular vision for production. So we have tried to implement digital intervention in phases, wherein the first part is establishing a backbone and standardizing and process compliance, which we have almost completed. And process automation, this is a work in progress, ongoing process. Certain things we have achieved, but still there is a long journey which we need to cover. Then once we have this basic thing in place, the backbone in place, in the second phase we are going to focus on IT-OT integration, which partially we have done, bringing in more and more sensors in our operation, so that when we talk about digital twin and the models, and these sensors will provide us with all the data, because on manual data we cannot perform all those analytics. So more and more bringing in more and more of intelligent equipment and putting in more and more of sensors, focus on sustainable mining, making our processes more intelligent, connected workforce, so that all our employees, they are able to perform the transaction from where they are, and they are able to perform any of their transaction irrespective of their geographical limitation, and they are able to communicate with everyone. And the third stage would be innovative automation, wherein we talk about advanced analytics, decision automation, artificial intelligence. We have not done much on the artificial intelligence, because as of now we are mostly completed the first phase. I would like to talk about artificial intelligence and say digital twin to an extent. Say we have a ore processing plant, crushing plant, screening plant, loading plant. We should be able to create a digital model for that with all these centers sitting at head office. I should be able to see which are the bottlenecks for my operations, where we can improve the efficiency.
What will be the best utilization of AI for mining, iron ore mining? Where would you like AI to be used?
Sir, as I,
Even if you are not using it.
no, sir, partially we are using like,
What will be the best? Just tell me. Where would you like to use it? Which will make the most economic benefit?
sir, mostly I would like my plants to use this AI tool, wherein sitting at HO, I should be able
Can I
to.
answer that, sir? Can I answer that, sir?
Is your ED
Yeah.
Digital transformation.
And so sales realization ultimately or sales realization.
that is not,
Yeah.
I don't think that's the best utilization of AI for mining. It's
सर जियोलॉजिकल सर्वे हम लोग एआई यूज कर सकते हैं कि इनपुट से कि हम किस तरह
Drone,
For me, we are in a business of size reduction. Right from the start, where I blast, the entire process is based on size reduction. So my most critical point, and which is my Achilles heels, is blasting. That's where I need a precision model for. I've been looking for that for the last 2 years. Unfortunately, nothing viable has been. Because once you are correctly blasting, even 30 years we've been talking about powder factor kam karna. I think that's the wrong solution that we are looking at. Powder factor ज़्यादा भी हो, but अगर आपकी fragmentation अगर सही हो, then the entire process becomes much more efficient. Whether it is crushing, whether it is conveying.
what I am saying, I don't know the answer. I am not a mining person. But that is the question perhaps you should ask.
But that is basically, we want blasting.
Your IT person should first decide that what is the problem to be solved, rather than first looking at a solution and see that we let us implement it in
Yes.
NMDC. Because, and I think another way of doing it, you are not the only mining company in the world. There are many mining companies who must be using AI and ML applications in their Australia or other mines. Just find out what they are doing. But, yeah.
Using complete virtualization, sir. They have the drones basically look at the your soil parameters, and then they decide where you can put the blast, what kind of blast should be put, and how much is to be dug, how much the drill has to be done.
Exactly.
So everything is that is done through the AI, and they have the complete virtualization system they are into.
That we have seen that. We'll
Yeah,
have to
but what I think is you need to spend more money into this thing than what you are doing. Perhaps it may not lead to immediate benefit, but I think it will lead to much more benefit in long run.
Yeah, it does.
What you are doing right now is not AI.
No, that's the tip of the iceberg.
It's just basic computer programming. It's not technology. Okay.
so this blasting part is also.
Chali, Rai, finish it off here. You don't have time.
Yes, sir. So these are some of the digital initiatives that we have
And
implemented.
so what you are showing is what SAIL has done and I was not expecting. I was expecting for steel industry, AI, ML और technology में क्या हुआ है और क्या होना चाहिए. क्या होना चाहिए वाला पार्ट नहीं आया और स्टील इंडस्ट्री नहीं आया. You are showing SAIL ने ये किया है, NMDC ने ये किया है. So what I had asked was कि you should come as a one session. You are different, but one PowerPoint showing कि ये, and on a macro level, not very. We don't have time to get into micro level. Okay, fine.
Next. My solution is more with respect to mining industry than steel, sir. I agree.
That's fine.
And these are the interventions that I talked about. These are the timelines with which we have implemented. Next. So then the digital initiatives that we have implemented, a brief on that. The first major step that we achieved was with implementation of ERP, which went live in the year 2021. And here the biggest achievement was that there was no single day when our operation came to a standstill, and we went live in a big bang approach, implementing this solution across all the locations, and we were successful in doing that. And what we have achieved is on the right side. Integrated business function, improved transparency, some of the benefits that we have achieved from ERP. Next. So we have been able to implement a management dashboard wherein on a real-time basis we are getting information about order production, dispatches, quality, these parameters, and which helps in monitoring the operations as well as taking a well-informed decision making. Next. So we have automated the process of production data capturing from the belt scale. So we are through MII, manufacturing intelligence, we are bringing it into SAP ERP. Earlier, when we went live on ERP, this data was being fed manually every hour. Now all this data are being picked up in real time from our screening and crushing plant to get the production data online. Next.
Chaliye, let us wrap it up.
Okay, sir.
We don't
Future
have,
Next.
we have to stick to time limits.
Okay, sir. This is MTSS which we have integrated with ERP. Next. Just 2 minutes.
There's one more presentation?
Yeah.
Yes.
Next.
I'll be very quick, sir.
I don't think you have time. We are already there. You have 2
Next.
minutes.
So I'll just show some of the future initiatives that we have planned, and then
After
I'll.
you have overrun your time. We will stick to time. Otherwise, फिर बाकी last में किसी को बचेगा ही नहीं.
So just I'll show some of the future initiatives that. So this is the future initiatives that we have planned, and that's where I end, sir.
Okay.
Thank you, sir.
Thank you, sir. I'll be very, very quick. I have only 8 slides and I'll talk only about one thing, which is cost effectiveness across the steel industry. I've segmented my presentation into 4 parts: recycling, mining, production and sale, and how AI and ML models can really help across the steel industry to optimize cost. Can we go to the next slide, please? So this is just a small code that I've shared before the presentation. I'll take just 1 second. So SpaceX recently caught a live rocket, made it reusable, and after the exercise was done, they gave a press statement that Starship and Raptor engine is primarily constructed using stainless steel. So this is a company that is built entirely around AI and ML using the data, and they said that this is the most cost-effective solution compared to more exotic alloys. We are talking in the age where steel is going to come back in a massive way. And these newer alloys, these newer technologies that will be used across the board everywhere. Next slide, please. So, sir, the first thing I want to talk about is the circular economy, which is the recycling industry in steel. And we have only 2 problem statements over here. You can just ignore the entirety of the slide. First problem statement is where to get the scrap from. Second is how to cost optimize. Only 2 problems. The first problem is on the left side. Predictive life cycle analysis, when a bridge, when a car is going to come to its end of life so that we can scrap it. And when we scrap it, what kind of steel, what kind of scrap is going to come out of it, and how we can reuse it. Second thing is market data and economic indicators, because steel plant is a logistic, intensive industry. We cannot transport over very long distances, like 1,000 kilometers. So the scrap, whatever it is being produced, it has to be transported over smaller distances. So when we plan a small recycling unit, this data, especially the smart city and infrastructure data, becomes very vital to us, that where the plant has to be set up, in which state and which district, so that our transportation cost is minimized. And sir, the open data platform of Government of India, this is coming out in a huge way, a very useful step for this particular aspect. Next slide, please. So here, sir, what I've done is a cost optimization model of an electric arc furnace. I'm not going to the maths and the details of it. On the right hand side, you can see there are 18 factors that we have included: what kind of scrap is coming in, how much weight it is coming in, whether DRI is there, yes or no, and what are the melting points and different temperatures. The idea of entirety of the slide is to explain that a machine learning based model and AI based model can actually predict based on visual cues what kind of scrap is coming in on the conveyor belt and what kind of scrap is actually going into the furnace, and optimize what is the energy required to be input to the furnace to melt it. The latent heat requirement is what we are minimizing over here. For an electric arc furnace where the cost is predominantly due to electricity, this becomes one of the most important equations over here. So when we talk about circular economy, these are the two very important aspects we want to highlight, especially in the medium and small term industries, that this is how you can cost optimize, and the investments that the companies will be making on AI and ML solutions, both the hardware and software part of it, they will have a very very small ROI, like 2-year or 3-year ROI window. Next slide, please. In the mining and sir, in the production, I think majority of the points have already been covered. As sir very nicely said, the most important challenges are where to drill and where to blast. So that point has already been covered. Next slide, please. In the production, sir, I'll just have a highlight on one singular point, which is the last point, product design and development. So in US, there is this Materials Genome Institute, MGI. They have worked with SpaceX and they are creating AI models predicting what kind of alloys will have what kind of properties. When we mix iron with what kind of materials, what kind of strength, both tensile strength as well as other form of parameters we are going to get. So before we go into production, before we go into testing, if we have 100 different forms of alloy giving us different sort of properties, it optimizes our cost and time schedule very much. So they have done some wonderful work, and this is very optimal time India can also proceed in this direction, having a unit or in-house facility where AI can be used to expect what kind of steel would be needed and how can we produce it before we actually produce it. Next slide, please. So in sales, sir, we have been talking about AI and ML for last 1 decade, and this is the one place where AI and ML is mostly maximum utilized. So all the 6 points you can see over here: demand forecasting, where exactly is the demand going to come from, and who exactly is going to buy my material, whether I am NMDC selling iron ore or whether I am SAIL selling steel. So this becomes very vital for us. The e-auction platform, what we are doing over here, because MSTC specializes in e-auction, is trying to segment customers. So one of the problem statements our CMD, when he joined this year, gave us that MSTC does about 50,000 auctions a year, and we have a buyer base of something around 4-5 lakh buyers. How does a person know which auction to participate in? So that customer segmentation going forward becomes one of the most important things for us, that the person, when he comes to our platform, he comes exactly which state, which district, which seller he's going to buy the scrap from, whether it will be ferrous, whether it will be non-ferrous, whether it will be hazardous. So this becomes our next journey forward, that how do we enhance our platform so that the users, ultimate people who are going to buy material from us using our platform, they can just go at one click and come that this is the material I have to buy. And last thing, sir, I would like to talk about is dynamic price optimization, wherein the biggest challenge for anyone across the industries that we have seen, both in petroleum, in steel, in telecom, is reserve price setting. ML models are the best tool that they are available in the market, seeing the economic forecast, seeing the stock market, seeing the commodities market, that what can be the reserve price of my material. And when we integrated with the AI solution that we talked about in the first slide, a predictive analysis, when my vehicle, when my bridge, when my building is going to collapse, based on what iron prices, wood prices and different material prices are there, I can come up with an estimate where to sell it and who to sell it at what price benchmark to sell it to. So that's all from my side. Very thank you.
Thank you. Very well presented.
आर्टिफिशियल इंटेलिजेंस और मशीन लर्निंग जैसे व्यापक विषय पर विचारोत्तेजक प्रस्तुतियों के लिए सभी प्रतिभागियों का और प्रस्तुतिकर्ताओं का हार्दिक आभार, धन्यवाद। और इसके उपरांत हम सभी लोग चाय के लिए एक ब्रेक लेंगे और सही ठीक 11:40 पर हम पुनः यहाँ एकत्र होंगे दूसरे सत्र के लिए। चाय के लिए VIP लॉन्च और हॉल के बाहर व्यवस्था की गई है, सभी आमंत्रित हैं।